Hello, everyone, and welcome to Module 3, Part 3. So this week we're going to wrap up data cleansing in Python for text with stop words and customer placement, some things that you just generally need to make text as uniform as possible. I'm going to turn off my video so you don't have to see my face while I'm walking you through the code. This is a code-only week, no slides. I'm just going to show you a few really nice things so that as you're going through the data cleansing process, as you're working on your projects, you can make things as customized as you need so that your data is ready to go. So goodbye. All right. So I'm going to share my screen and walk you through this code. Hopefully, a lot of it is self-explanatory, but if you ever have issues with it or you're not sure how to apply code to your specific data set, definitely let me know. Feel free to reach out anytime. So as I said, we're going to go over data cleansing today. We've got our agenda at the top. So just a brief introduction, get that environment ready. And then we're going to go into stop words, stemming, lemmatization, part of speech tagging, and customer placements. So some of these are more the customized part. So stop words and part of speech tagging with customer placements. Those are more as you need them. They're really nice. Stemming and lemmatization, we're going to go over because as you're getting things as you like, there are a few really key methods that I would like you to explore and start to use. And those are all, again, going to get your data as uniform as possible. Because as we talk about text, because every single document is going to have a slightly different flavor of text, as people talk about things in slightly different ways, we want things to be uniform so that we can actually analyze the entire data set and not just call out the differences in, say, part of speech. So with that, let's get going. We're going to use the BBC News data set again. We're going to use that quite a bit. I've got a few other practice data sets that are pretty clean and ready to go. But I like this one because it is more recent news. The other news data set one I have that I like is from 2013. So some of it's a little outdated and you start to see references that aren't as exciting. So hopefully this one at least shows you some top news, however depressing it might be. So we're going to get started just as we always do with these package imports. One of the things I have noticed on a few of your assignments is that you might be forgetting to run this before you run all the other cells. You do want to make sure you're running this in order because order matters. And if we don't import a package, we can't use it later. So here we're starting out with pandas, which is the how we get things in a data frame. NumPy, NumPy, that's just numbers because native Python sometimes doesn't work well with numbers. Requests, I don't think we actually need that this time. I just always put it in. It's for when we're web scraping. A few settings so that we can actually see our data. And then we are going to use the count vectorizer and the TF-IDF vectorizers today. We're not learning anything particularly new about these. We're mostly just using them so we can understand what the data cleansing techniques actually do. So we run this. Again, you can press the run button up here, or you can run this by pressing Shift and return or Shift enter. So Shift return if you're on Mac, Shift enter everywhere else. So Shift enter. And you always know when it's running when there's a little asterisk there. So if I do that again, it runs honestly so fast that it just goes away right away. But that's what it is. And then the line number is so you can reference it later. You'll notice some of yours are not going to be completely in order. It actually went from 2 to 4 with me. But as you like change things and maybe have to fix a mistake, you're going to see some numbers kind of jump really high. Just try to make sure that they are in numerical order. So even though you might jump from 4 to 7 to 22, as long as it's in numerical order, that's okay. What you don't want to do is run something down here and then change your packages and not run everything. There's always a chance that something you've done has just kind of messed up the entire file, and we don't want that. So we're still running in this file. Another issue I have seen is that occasionally when you're putting this in, you do have to have that CSV part on there and make sure your file name is exactly how it is in the file. So in this case, it's BBC_news. If you need to, you can always copy and paste the file name, but remember that CSV. Now you can use Excel files. We just generally don't recommend them because they don't play nicely with text. Occasionally, if you open something in Excel, it just kind of doesn't work so well. So what I would recommend if you have an Excel file is to open it in Excel, save it as a CSV, and then don't open it again. Don't do any edits, just so you can still use this really nice, easy command, read CSV. You have a CSV, and then hopefully your text is not messed up in any way. There's lots of corruption and things that can happen in Excel, unfortunately. So we read in that file. I always call my files DF for data frame. That's pretty common in Python. You don't necessarily have to do that, but it is really nice and helpful. And then honestly, most of my code you can just copy and paste because it's always DF. I name things later on in here just so you know exactly what we're talking about. But if you look at any of my research, any of my other classes that use Python, it's almost always DF for data frame. View the first 5 rows with df.head with the parentheses, and you see that there. And then you can view the size of the data set by doing df.shape. This one does not have parentheses, so just always remember that. Or if you don't remember, if you put it there, you'll get an error. So all we need to do is forget those, put it there. So we have 34,072 rows and 5 columns. So just like we've had every other time, and you will see that data set shrink and expand as we go through this data cleansing process. So now on to stop words. We did talk about this briefly because it is a parameter setting with all of the vectorizers that we've used. But in general, stop words are words that have no inherent impact on the meaning of text. So they're useful, and I've used this example a few times in this class. They make us not sound like Cookie Monster. Me want something, you do this. It adds English grammar. It follows our rules, and it makes it more understandable, but they don't add actual meaning to the text. So some of the common words are like, the, as, of, and those are tricky because we know like is also another kind of word that might be useful. But in general, these are words that don't have impact on the meaning of text. And we likely will remove them because if something doesn't have meaning to the text, if it doesn't add context or anything that we would need in our analysis, why are we dealing with it? We're going to do this using NLTK. That's Natural Language Toolkit, really common package for text mining. Some of the other ones you might see, Spacey is out there. We were moving towards Spacey, and then it kind of just paused in development. It hasn't had a lot of great features lately, in my opinion. Some of you might like it better. There's always new packages coming out, but for me, NLTK is a tried and true one that works very well. I haven't had issues with it, so I like it just for its consistency. Now, the first time you do NLTK, you're going to have to pip install. After you do that, you can just comment it out so you never have to do it again. So I'll show you just what that looks like. Pip install. And it's not going to hurt anything if you do the pip install and you already have it. It's just going to say requirement already satisfied. That's totally fine, but I'm still going to comment that out. Now, important note here, when you run the cell right here, import NLTK and then NLTK.download, you are going to get a window that pops up. This is one of the very rare few packages that actually interacts with your computer a little bit more than other packages. So let me try showing you. So import NLTK. Nothing really happens there. You just need that to use it. But we do need to download the components of NLTK. To do that, we're going to do NLTK.download with the parentheses. And you'll notice there's an asterisk and then it says showing info and you don't see anything else, it's actually because it's on another window of my screen. So I'm going to drag it over. So it showed up on another I have a couple of monitors up. It showed up on another monitor. For you, it might show up behind your window or it might show up minimized. It's really easy to miss. So if you're ever not quite sure where it is, you can always go down. If you're on Mac, you can right click on your browser and say show all windows. There's lots of things you can do. But it will look just like this, except yours will say, I think it says not installed or something similar. All you have to do is click all and then download. So that's it. We mostly use, let's see, I think we mostly use the ones in the popular package. You can look at all packages and see what you might use. It's honestly just easier to do all of NLTK. It doesn't take up that much room on your computer. It will take a few minutes to run, but then that's the only time you have to do that. To get rid of this and to make sure your code continues to run, because see, it's still stuck, I can't run anything else, you just have to exit out. And then you see that that's now done running and it shows true. So I left that little note there. If it shows true, you're done. If it has a little asterisk, it's still running somewhere. So make sure you download what you need and then exit out of that window. So this is all just the first time you use NLTK. Once you're done with that, we don't have to do any of that again. So now we're going to look into some stop word packages. I'm going to briefly go over this just so you have it. But in general, stop words, because everyone has a different opinion about what a stop word is and which package might be more helpful in different contexts, I'm going to show you two. One is from NLTK, and one is the built-in one from scikit-learn. And some people get confused. Scikit-learn and sklearn, they're the same thing. So I'm going to first import this. So from NLTK, import stop words, and I'm just assigning it to this variable NLTK stop words. When I do that and I look at the type and length of the stop words, you can see that it's a list and it has 179 stop words in that list. And you can see the actual ones below. So some of them are just the kind of normal, lots of pronouns, lots of in, out, below, some of these that are maybe a little less common. But if you have shan't in a text, it will now pull that out. So 179 words. The scikit-learn one is pulled out in a very similar way, but you'll actually see instead of a list, it's a frozen set. It has more words. It has 318. And the big reason why I'm showing you this is that NLTK is a list. Scikit-learn is a frozen set. You cannot change a frozen set. Lists you can change. So it's just something to know if you're going to maybe use a combination of these, if you want to add your own custom stop words, there's going to be some situations where you might get some errors. So I'm going to just walk you through it really quick. If we look at NLTK, the list version, it's really easy to remove words like this. So dot remove, and you just remove it. So this one removed before and after. And you see it went from 179 to 177. The issue with this is that if you want to remove something that's actually not there, for example, if you can't remember if a stop word is in there, or if you're running your cells a few times and you've already removed something, it is going to give you an error. So when you get this error when you're running through this code, don't worry. It's just saying, hey, blue is not in the stop words list, so you can't actually remove it. If we use sets instead, so instead of a list, we use a set, it's a little bit easier. There you go. So you can see where we wanted to keep these words before, after, and blue. It's actually remove words. But anyway, if we wanted to remove before, after, and blue, you see here that it still lets us, even though blue is not in the stop words. You can also add things to sets by subtracting and adding, but you cannot, you can subtract, but you cannot add. So you can't add these words back. All of this to say, this is my favorite method. I take the scikit-learn stop words and use them as a list, and then I just add things like this. And then I don't really remove stop words unless I really need to. And if I do, I am just more careful about it and make sure it's actually on the list first. So this is my favorite method. I do these stop words, and I always create a custom variable called my stop words, and I can add things to it very easily like this. So in this case, I'm adding Mr., Miss, and then 000. That's because a lot of numbers end up with that 000 if there's like a comma in it, or if we're saying 250K for 250,000. Just sometimes those zeros pop up. It's one of the most common ones. So I'm going to run that. The other way you could do it is also just take the NLTK stop words plus the scikit-learn ones, and you can just add them together in a word list. And then you see we have that 318, 179, and now we have 497. Anyway, all of that to say, be careful when you're looking at stop words just because of the data type of the list or set or frozen set of stop words. And my recommendation is to use this version where you're creating a list to start, and then you add them with that plus sign. And then when you're adding a list, you have to add another list to it. So that's why it's got these brackets around it. Anyway, so all of that to say, let's go back to our, we're going to use TF-IDF. Now, if we use this, I'm going to first start with just the default stop words that we can add here. So stop words equals English, add it or transform our DF description. And you see that we get 28,344 tokens. Now, if I do this again, actually, let me show you what those actual features are. And I'm just summing weights. The weights don't really mean anything in this context, but the higher the weight, the more important. And you will see that the top words by importance are says, world, BBC, people, England. Now, if I change this and actually use my stop words instead of just the built-in stop words equals English, you'll see we now have 28,341 tokens instead of the 28,344. Super small difference. And it's just because we changed what words are going to be in the stop words. But you can see this one just changed it by, I think, 3, right? Yep. It can change pretty dramatically, though, depending on what stop words you add and take out. So just make sure when you're using stop words, if you're going to use the built-in one, great. Just know what's in there and when you might actually want to use my stop words. When I run this, so it's actually the same. You will notice the weights are slightly different just because I have less words now, but in general, they are the exact same. Now, if I'm looking at this, the first thing that stands out to me is BBC. So BBC is the name of the data set. We know it's going to be referenced multiple times in these articles because it's things like BBC News says, or according to a source at, or from BBC, and so on. So we might want to remove BBC from the text, and we can do that by adding it to the stop words. So in this case, we can say my stop words equals my stop words plus BBC. And remember, it has to be a list, so it needs those square brackets. And then if we run this again, BBC is now gone from our top words. I am now going to move on to stemming and lemming. So, when we're talking about stemming and lemmatization, we are talking about looking at the tense of words, the part of speech, and we want to understand how do we get words to their base form. I'm going to just go over this in very brief detail. I've got lots of text within this code so you can walk yourself through. But the main thing I want to point out here is that stemming is a more rudimentary way to get words to their base form. And it doesn't always work because English is a tricky language. Lemmatization is a more complex way to look at stemming. And in this case, it looks at a more data-driven method. Instead of having a built-in list of how it gets words to its base form, it tries to look more at part of speech. There's lots more customization options. And I'm actually going to skip ahead. So there's Porter, there's Snowball, Lancaster, Porter 2, and then lemmatization. I just use WordNet Lematizer. It's a really nice one that's pretty easy and it's built into NLTK. Spacey also has one that's, I would say, okay. Again, I like NLTK. And what's neat here is that for lemmatization, you can either do the just basic lemmatization where it just kind of does the built-in method. And here you can compare it to the stem version for Porter, Lancaster, and Snowball. So if we have text that's cats running, ran, cactus, cactuses, cacti, community, and communities. So all of those words, you can see what the stemmers do. So it gets cats to cat, running to run, but now ran is also still ran. They have different methods of dealing with cactus. Porter just takes the S off the end of the word and makes it not a word anymore. Snowball actually does it pretty well. It does cactuses correctly, kind of, just a cactus. Cacti to cacti, but then you see Lancaster doesn't do this one right. And then for community and communities, you notice it actually creates not really a real word. So commune without the E, community with an I at the end. Lemmatization does a little bit better. So it has, here's the original words again, and it does cat. It didn't do running correctly. It left it as running. We have ran, cactus, 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 which is good. We wanted all three to be cactus, and then community and community. So you see that it's working a little bit better. Now, a cool thing with lemmatization is that you can also add in the part of speech. The default is noun, but if you notice a lot of your text that it's not quite working correctly is a verb, we can actually say part of speech equals verb. And now we see cat, run, run, cactus, cactuses, cacti. So it did not do these quite as well because they are nouns. It's just focusing on the verbs. So just kind of keep that in mind. I know that's a lot for one day, but stemming takes the words to their base form and it's wrong a lot of times. Lemmatization is a better form of it. It's more complex, but it's usually returns better results. I recommend starting with WordNet Lematizer. And if you need to, you can change the part of speech to verb if you find that that's a particular issue for your data set. Now, why we're doing this is because we can actually compare and contrast the feature space. So if we are putting for words to their base form, we are going to get a smaller number of tokens. This is because of instances like this, where we have cactus, cactuses, cacti, and now they're all cactus. It'd be the same for if it got running right. Maybe we had ran, running, runs, and it corrected or changed everything to run. We now have less tokens to deal with. So in this case, this one is going to be the, let's see, oh, just the original. So original. Now we can apply the Porter stemmer. This code is really important just so you learn how to implement that text or the stemmers, the lemmatizers. We're doing the column name dot apply. And then we have this. This was defined earlier in the code. Like this one is SS for snowball stemmer. Let's go back up to Porter. So PS equals Porter stemmer. There are parameters you can use, but I just use the Porter stemmer as is. So that PS is the Porter stemmer. And now when we're down here, where to go? It's just that PS dot stem. And we're using Y because it's just a variable, like an iterator to say for every word that we have, stem it. So you can usually just copy and paste this as long as you have said PS equals Porter stemmer earlier in your code. And this actually adds a new column to your data set to show the Porter stemmer version of the words. And it will take a few moments. So now you can see the description, and then P stem is that new column we just created. So this one starts, and honestly, this data set is pretty, it's okay for stemmers and lemmers. You'll see it's not doing anything drastic. You will also see, so when we do this rudimentary stemmer, these are really hard to read. It's like looking at maybe text from an elementary school student that doesn't quite know how to run or to write yet. Try to flee, TRI. If we want to see, I'm going to run this just so you can see the top features, and you see that some of them are normal, that says world, England, say, is hi really one that it's supposed to be? Wa, W-A, H-A, ha. I doubt it has ha that many times. And if you look further into this, you'll actually see that it was, and it just took off the S. So you see why stemmers can be a little bit tricky. If we instead apply the lemmatizer, again, same type of implementation, it still has a struggle with was, but it's trying its hardest. So this is all to say you are going to find weird issues in your text. Maybe stemmers are the way to go for you, maybe lemmatizers. What I want you to do is be able to really look at, so now we have df head. I have the original, I have the stemmed, I have the lemmatized version. Look and compare them. Which ones actually make the most sense for what you're doing? It might be that you want to use the original. It might be that you want to use the lemmatized version. Maybe use the lemmatized version, and then obviously you need to do lowercase. Maybe you do a few iterations of this, but just know that these are out there. This is another thing that's just kind of out there, part of speech tagging. So you saw how we did the WordNet lemmatizer with verbs. You can also do that here using this. So POS equals V, so part of speech equals verb. And you see that that was is now gone, that WA. And these are making a little bit more sense. If I show you that. See, these are now looking a little bit better. We're still looking at words. It doesn't always, see, remember this is a noun in this case, so it didn't fix this part. But you know, it's trying. It started it. Yeah. I truly wish in text mining there was a one method that I could show you that fixes everything, but that's not the case. So this is the part where some people find it frustrating, some people get excited. Just take it one step at a time and just kind of see what's out there. Use my code as much as possible. And don't be afraid to use ChatGPT to fix your code if it's not quite working. Let's see. So I'm just going to show you a few more of these. You can tag parts of speech. So it's this nltk.pos_tag. I've used this before working with speech pathologists when they wanted to just tag their speech really quickly and see like it does each word, which is pretty cool. And then if you wanted to do this, it actually shows you what everything means. So like IN there is a preposition or a conjunction. NNP is a noun, proper, and singular. And then you see even commas are there. So it shows you commas, shows you dashes. It'll show closing and opening parentheses. So it is really neat that it shows you that part if you ever need it. I have only needed it for the WordNet limitizer, but I have explored projects where it's more about what parts of speech are people using? Are they using past tense and someone else changes it to future tense, just kind of looking at how we speak to each other. So just know that's out there. And then you can see how it kind of uses this, and this is why some of it didn't work as well, because some of them are now and some of them weren't. This is going way further into natural language processing than this class really allows time for. So if you're interested, there are tons of different resources on that. Just look up NLP. To wrap up, I'm going to show you custom replacements. And this beginning part, I'm just going to run so we have it. But in general, if we want to say, take one word and replace it with another, we can do that pretty easily in Python. In this case, the first one is let's replace an A. Every time we see A, let's replace it with B. So cat would now be CBT. We can also change a whole phrase. We can change Bank of America to B of A, and it will replace it here. My preferred method is using dictionaries where we actually can list out multiple ones. So let's say if we're looking at a data set that's talking about sea and marine life, and people are going to call it ships and vessels and boats, and we just say, let's call it a boat. Every time it's a boat, let's do that. So in this case, we're saying if it's a ship, call it boat. If it's a vessel, call it boat. And that usually works. So what is the name of this vessel becomes what is the name of this boat? Can you ship this to Cleveland? You see, it actually also does the same thing. Can you boat this to Cleveland? So just know some part of speech things come into place. And if your word is also used in different ways, it's going to do it no matter what. What is the name of this battleship? So even though ship is just part of the word and not the entire word, it still does the same thing. What is the name of this battle boat? So we run into some issues. And then another common one is for addresses. You can change things like north to N. And what you would do is just replace the word with the lowercase version and then change that. So then now it's 123 North Anywhere Street instead of the full north word. Contractions, I don't use these as much. But the main thing I want you to see, the final takeaway, is that it's down here. So I create a dictionary and I say, how do I want to, like what words do I want to replace and with what? I noticed the Manchester Arena was on there quite a bit because there was a bombing. So I said, instead of Manchester Arena, which can be Manchester Arena, it could be arena, it could be the name of the arena, let's call it Man Arena. So just combine the words. So now it's there. And then I have this all written out. You don't have to change a thing as long as you called your dictionary news underscore BICT. If you change that in any way, all you have to do is change it down here. But if I run this, now I can say this code says take that description, that clean text, or that original text, and apply this multiple replace function. And I'm calling this, so that's my dictionary. Again, if you change the name of this, just change it down here. And now you see it's almost exactly the same. So this dictionary does take everything to lowercase. Let me see, actually. I don't remember if oh, there we go. So Manchester Arena, you see how the stemmer called it Manchester Arena. Some other things do other things. So let's just call it Man Arena. And now we always know it's calling the Manchester Arena. It's always going to be talking about that if it has that phrase. So that was a little bit longer one. Thanks for bearing with me. In general, this entire module was about how do we take our original text? How do we take our text that is not so clean and it is using lots of different words. It's using different words for the same thing that we're talking about. How do we make it as uniform as possible and whittle down our data set to just what we need? Again, I know it's a lot. I know a lot of you have not used Python before, and some of this is more advanced. So what I want you to do is just try it. We will work through any of the code bugs and weird things. The main thing is I want you to know what is stemming, what is lemmatization, and what can they do for your text if it's needed. So with that, I can't remember what number it is, 5. Your homework is due at the end of the module. I did kind of a longer homework for this next assignment. So just kind of know it's supposed to take 2 weeks. You should be about 1 week into it. So hopefully you've been working on it. And if you need any help, feel free to reach out. I will see you next time. Bye.